a European company. They have been around since the late 80s. It's a family-owned operation. Started out very small. It has 7 international patents on the way they manufacture fittings. And it truly is a bit different than the other guys. And Tega is making an investment in the $5 million range to come over here and participate in the U.S. market. So they have a major commitment. What makes us unique? There's a couple things. First of all, the size range. We're the only manufacturer in the world that manufactures over a 28-inch electrofusion coupler. We're taking it sort of to the next level. 1/2-inch through 63-inch IPS sizes, and we can basically manufacture any DIPS sizes. We're saying through 48-inch. So we're expanding the size ranges of the fittings available out there. And then also something that makes us unique is we don't just manufacture one pressure range. In fact, the first question that we ask, we talk pressure. We don't really talk SDR and all that sort of thing. We start asking about pressure and you know, what's the application? Is it liquid? Is it gas? And then we start trying to provide the customer with the appropriate fitting for the application. We manufacture gravity couplers. You know, a lot of the 42-inch lines out there, they're non-pressure applications. So, you know, why should you use a 240 psi coupler if you got a gravity flow line? So we make gravity flow couplers, 100 psi couplers, 240 psi couplers, or couplers in that 200 to 240 psi range for full pressure. And then we also can make specialty fittings, all in some sizes all the way up to 475 psi. One thing that makes it unique, it's a layering technology. This is a 8-inch coupler that we did over at Specified the other day, and you can see it's actually layers. That's what gives them, it's really the technology that enables them to do those larger and higher pressure couplers. For example, this coupler right here is a 24-inch IPS 240 psi rated coupler. But then we also make couplers like this. Let's say you've got a landfill gas application that's just vacuum pressure, SDR 17 pipe. Well, this is a 10-inch IPS 100 psi coupler that would be ideal for that application. And then all of our couplers are ASTM D2513 for gas. Another very exciting thing that we're bringing to market are fully pressure rated electrofusion branch saddles. And why is that a big deal? Well, up until now, as far as electrofusion branch saddles, the size ranges have been limited, and also the pressure ratings. You've got some electrofusion branch saddles, but some of them, they're really sewer saddles. They're only rated to 50 psi. This particular saddle right here, this is a 12-inch IPS by 4-inch IPS electrofusion branch saddle that's rated at 240 psi for water. And now we're going to take the next step into having branches, you know, that are very, very easy to install, require very, very little equipment, and it's going to take us, hopefully help us advance polyethylene into the water market. As far as pressure ratings, anything with a 12-inch outlet or smaller is fully pressure rated at 240 psi for water. Then 14-inch, we go down to 195 psi. 16 and 18-inch outlets, I think we're at 165 psi. But still, you know, it's going to get you in most applications. And then our largest outlet is a 20-inch outlet, and we're derated to 125 psi. But still, pretty high pressure rating. And again, if there's a pipe out there, we've got a branch saddle for it. For all main sizes, we go from 1.25 inch on our branch saddles we can manufacture a 63-inch branch saddle. 63 by 20 is our largest branch saddle that we can manufacture. We do those in ductile iron by ductile iron, or IPS by IPS, ductile iron by IPS. We can do it in any type of combination. What we've chosen to do, just coming into the market, we're focusing on 16-inch mains on down. This is the other equipment you have to provide. Basically a ratchet strap with a couple hooks on it. And you basically just ratchet strap them up to the main, and basically you need to make it really tight enough to where you've got a good, solid contact.
Does it make any difference if you drill the hole before or after you place the saddle on the main?
You can do it either way. If you have a non-pressured main, then you can take that saddle, put it on the main, and mark off the hole, drill out the hole, and then attach the branch saddle and fuse it on. Or you can actually take and put the branch saddle on and fuse it on, and then allow it to go through the cooling time. And once you're through with the cooling time, then you can core it out that way. Or, of course, one of the big things that's going to open up is with the full pressure rating is hot tapping live mains. With this branch saddle, you can actually fuse it on with a flange adapter and attach a hot tapping valve, and now we can do live taps on mains for just about any size of pipe. Then on our smaller branch saddles, anything with a 2-inch outlet on down is going to be like this. Basically everything, all you have to do is provide a wrench to tighten this strap down to the main. And all of our smaller branch saddles, anything 12-inch and under is fully pressure rated for 240 PSI. The other thing that we're working on is, and we will have this product, but we're working on a female CC and IPS thread, so that you can, again, you have CC thread, screw in a corp saddle or a corp stop, and actually hot tap the live mains. These are available through in the 2-inch outlets, 18-inch IPS, and 18-inch dips on down. So it gives you a really nice way to tap mains on anything 18-inch on down.
When the fusion process is over, do you take the strap off?
The strap would normally you'd probably just leave it on. The strap is basically a throwaway item. We manufacture a full line of tapping tees in both IPS and ductile iron pipe. So I don't think you guys have very much ductile iron pipe sizes out here, but there's certain parts of the country where for water products the engineers are specifying ductile iron pipe sizes. So we can do both, and our tapping tees basically the same way. It's ease of installation. Requires very little equipment, and we have a stainless steel cutter, and again, it requires a hex head wrench that you can go down to your local hardware store and provide the hex head wrench. Of course, when you go down and you turn the hex head wrench, the cutter self advances, and it goes through and it taps the main, and then the coupon is retained in that stainless steel cutter, and then you back that all off as far as you can, put the cap back on, and then you've got a live main. So another thing that we're bringing to market is electrofusion, what I'm going to call specialty fittings. These are our T's and 45s, 90s, reducers and caps, and this is sort of something we're bringing into the market, kind of developing the market. The couplers and the branch saddles and the tapping tees have the biggest focus. We manufacture our own processor. We get to our larger fittings, it requires additional power. We've got this unit inside a Pelican case, and the actual unit itself is sort of floating here in the middle of this case. This unit right here, it's truly a universal unit for the U.S. market. This unit can fuse anybody's fittings. The other thing, as far as ambient temperature, when you're looking for an electrofusion box, you want to be looking for a temperature compensated box. Just like in the butt fusion process, if it's 20 degrees outside, you're not going to have the same fusion time as if it's 100 degrees outside. It's different. You compensate for the temperature. So electrofusion is the same way. You want to have a box that measures the outside temperature, and then it will adjust the amount of time that's required to do the fusion. And this box takes all that into account. Logging the fusion parameters, this box will basically record. When you do a fusion, it records all the parameters. The date, the time, the size of fusion, how long it took. It records up to 6,000 fusions. And then all that material can be downloaded to a printer or to your computer. There's 3 ways you can do the fusion. It's got a barcode scanner, and then if that becomes damaged or you're not able to do that, all fittings out there on the U.S. market are supposed to have a 24-digit number right below the barcode, and that basically has all the parameters that it needs for the fusion. Then if all else fails, there's a third option, time and voltage option. There's actually that information. On every fitting, this particular fitting requires 42 volts for 1,320 seconds. And then the cooling time is 45 minutes. All that material, all that information is on the coupler. You can input that information into the box. There's four key things in doing the process. When polyethylene pipe is manufactured, almost from day one, it starts developing an oxidation layer. Like anything exposed starts getting oxidized. It greatly reduces the melt flow characteristics of the pipe material. The other thing is, when you get to large OD pipe, the pipe here tends to be oval. We have to re-round that pipe back. If it's more than 0.5% out of round, then it's not going out the door. So that coupler right there is round. The process is really simple in getting pipe back to round, measuring the OD of the pipe, and figuring out where your largest diameter is, and marking it off. And then if you compress that back into the proper dimensions, couplers go on. It brings everything else back in around. Yeah, we have 2 sets of re-rounding clamps for the larger OD couplers, and they have to be pretty heavy duty. It's basically a couple half shells, some ready rod, and we tighten that up and basically compress the pipe. This one is basically designed for 24-inch through 42-inch pipe. And then we've got another one that's basically the same thing, except we've extended it out, and we recommend that for 42-inch through 63-inch applications. So we've got scraping of the pipe, re-rounding the pipe. The other thing is cleaning the pipe. We're moving away from acetone because apparently it leaves a residue on the pipe. This is a product that we stock and Specified has on the shelves. It's 96% alcohol, 4% deionized water. So dirt and electrofusion don't mix. Of course, water and electrofusion doesn't mix. If you have water in the line and it's moving, then you need to get that stopped before you do the process. One of the other things is alignment, pipe alignment, making sure you don't have this sort of thing. You got pipe going in at an angle. If I've got pipe going in at an angle, it's creating a stress point on one side of the coupler, which leaves a gap on the other side. When this starts getting hot and the material starts melting, the material has to go somewhere. So what happens if you have stress on this coupler and leave a gap over here? Well, there's a possibility that you can have a gap and that molten material will actually escape, and you'll have molten polyethylene squirting out. What you're going to find with the Tega coupler, the fusion time is quite long. We have a long heat soak time and melt time. Our pre-warm barcode is figured into our fusion time. And so we have a long enough fusion time where we allow for that expansion to take place and all the melt to take place necessary for a good fusion. When you get to larger OD couplers, the power requirements are such that you're only fusing one side at a time. We actually go to a higher size range. We go to 16-inch before we go to one side at a time. So that's another thing that makes the fusion process faster in the field. The first thing that we need to do is of course scrape the pipe. And what I'm going to do with this coupler, there's a cold zone, and we want the ends of the two pipes connecting right there in the middle of this cold zone, right in the middle of the coupler. And you want to watch the, I don't want sort of this thing going on where you've got an angle, because there's a possibility if these things are meeting and you got a pipe at an angle, that it's not all going to be fitting into the cold zone. So we want two ends that are nice square ends, and I'm going to measure to the center of this coupler, and it's slightly under 8 inches. What I would do is I come over here, and I'm actually going to measure down to 8 inches. And for scraping purposes, I'm going to mark it just a little bit beyond that, because we want to scrape just a little bit beyond that. So I would actually mark it just past 8 inches. And there are a number of scraper tools out there. This particular one is manufactured out of Germany, and it's marketed by Friatech. It is a really nice tool. They say that it's 6 through 28, 8-inch. It really works off of revolutions. So it's not really limited to pipe diameter, it's limited more to pipe thickness. We have scraped as high as 36 with this particular tool. The other thing is that as you push this down, you can move this back and forth. There's a little spring operated thing that releases it. So you just basically move it into place, and it's really simple. See, as I tighten down, I want to bottom out right here. And then, of course, there's a spring-loaded cutter here. And see, it's taking this small little strip pipe off at about 8/1000ths. It really works great. Again, you can do this twice, especially if your coupler's a little bit tight. Another thing that I need to talk about, this piece right here, when they do the guillotine cut at the factory off of a piece of pipe, it creates heat, and what happens is you get what's called toe in. There you go. Thank you. This piece is actually undersized, and sometimes it's hard to find a size to re-round, because a lot of them are undersized. But normally what you want to do, since we've actually got less than 24 inches on this particular, if you can, you might want to take a chainsaw cut and cut back 6 inches or so to get away from that toe end. And a little tip on the re-rounding tools, from personal experience, you want to set up the re-rounding clamps down on the ground rather than sit there and wrestle them and try to get it all set up on the pipe. So what we normally do, now this is 24 to 42, but really with 24-inch pipe it's a bit bulky. It really works better with 28 to 42. But what I would do right here is I would set it up something like this. Then I want to measure and set this thing up at about 24.5 inches wide. So we've got it all set up like this. This point right here is 24.5, and then we take two guys and we take, this is the low side, this is the high side. We take and we put it on the pipe, and then we rotate it so that the center points right here are right on our mark. And we want to set that back the 8 inches, we're going to set the edge right here to our 8-inch point, so we can create a, not only do we have the pipe rerounded, we also have a stop for the coupler, and it's going to pound it back and stop it at the center point. If you can visualize, we've got these clamps on, and we've tightened them up, and we come back here and we measure, and this is right on 24 inches. So now we have to do our cleaning process. So I'm going to take and I'm going to clean make sure that the fitting is clean. Take my wipes to the inside of the fitting. So now we would be at a point to where we're ready to install the coupler.
You do a lot of vertical installations with us?
What's that?
Simmer down now.
Well, actually, sometimes with landfills, this is going to open up opportunities. Sometimes with landfills, they have riser pipes going up, and our gravity couplers, it's an excellent application for that. Any type of vertical application is excellent for electrofusion. So we haven't been pounding these things down all the way, but I mean, if you guys want to come up here and look, I could have this thing down within 2 or 3 minutes and centered. It's a nice, real nice fit. It's tight, but it's not so tight that I got to take a big sledgehammer and whack it. So this processor, it's really simple. It takes you through the whole process. When I turn it on, it does a little self-test. Checks to make sure the unit is within calibration. And then it comes up and it says connect fitting. So you get 3 sets of leads with the processor. The white ones are the ones that do our couplers. Just for your information, we have the same lead size as a Freatech fitting. The central fitting is a little bit larger, the adapters. They're at 4.7 and we're at 4.0. So, but they're all contained, that's part of what you get when you buy a unit. So I'm going to So then when I connect the fitting, next thing it says is scan barcode. So basically scan it over, and you can scan it either way. You can connect the leads either way, it doesn't matter, and then you can scan it either way, right to left, left to right. So then it reads all the information in, Tega, coupler, it's giving me the size of the coupler, saying it's going to take 42 volts, 21 minutes and 56 seconds. I'm at the point where I would press start and it would start the fusion. What I'm going to do is just, there's 2 arrow keys right here. You just take your fingers and you press down both arrow keys at the same time, and it takes you into basically a manual mode. There's 3 different selections here. There's a manual barcode selection, and I'm going to go down to that and select that. And if you'll see, it has the 24-digit barcode here. And my arrow keys select the number, and then your stop-start button or your left-right button. You get all that information put into the processor and then press start. The stop button, anytime you want to go backwards on the unit, use the stop button. We have a line of scraper tools that are real nice. Like I told you, every scraper tool has its advantages. What I would say about this, these go through, we have sizes through 12 inches. And this particular tool, some of the utilities, they don't want a hand scrape for a tapping T or a branch saddle. They'd rather do a mechanical scrape. So this can actually insert, I could insert this right in the middle of the main line, scrape out a little section for a tapping T or a branch saddle, or I can take it and I can put it on the ends of the pipe and scrape out a section for a coupler. This one's real simple. You just tighten it down. It's got a pressure sensitive coupler or cutter blade down there, and then you, wherever you set it, you tighten this down so that it doesn't, so it sets it. It self-advances.
Try not to lose a finger in this process.
Thing you want to do is take a hand scraper and make sure all those burrs, little debris is off. Take and clean the pipe. Now these smaller couplers do have stops. You already clean that?
Yep.
So we can just,
Inside the fitting?
yeah, there's stop inside here.
Or you clean it?
What's that? Yeah, I should have done that. Scan the barcode, and it's giving me all the information here. And it's saying press start. Tell me to disconnect output leads, and it's saying fusion completed successfully. So now, basically, remove the leads, move on down the line, do the next fusion, and we just need to let this sit here for 10 minutes before we move the pipe for pressurizing.